My talk is titled Scientific Inquiry, Sensory Experience, and the Creative Process. I use data in my work. Some people would call it, I'm a data sculptor. I'm not sure I like that term. I essentially take data as a conceptual resource. The themes I like to choose for my data are water related, so both natural patterns and sort of human impacts on water systems. And I translate the two-dimensional data into three-dimensional forms so that viewers can have a different way of accessing the information, a more intuitive format for them to understand some of the patterns and impacts that are happening in different water places. So all of my work starts with a very personal experience in a natural landscape, and that's where I sort of start this path to inquiry into a specific data set. And I start with this image because I visited this site and it had a really profound impact on me. While I was studying in college, I have a degree in furniture design, so this had a big impact on the work I made at the end of my BFA that I got from California College of the Arts. And this site is Land's End. It's the site of the former Sculptural bathhouses. This is the Sculptural bathhouses as they were originally created, and it was a series of 7 pools. The pools were controlled by the tides. It was the largest indoor swimming pool at the time that it was built, I believe in 1894. And the tides recycled all of the water, I think 2 million gallons within a couple-hour period. It wasn't very popular and it ended up burning down in the 70s, and now it's this Golden Gate National Rec site, and you can go here and climb around, and there's a cave and some really cool stuff. And being in this space, the most dominant feature of the landscape are the tides, both in the sense of the historical context of the pools being controlled by the tides, and sort of people harnessing the tides for their own purposes, but also the fact that these are ruins now, and the tides are slowly kind of taking them back into the ocean. So this really inspired me to start looking at how we study these natural places. It's a scientific lens, and if you start doing some research, you can find that the NOAA has an online database of all tide stations across the U.S., and you can, as you know, the general public can access these databases going back as far as the stations have been there. It's an online archive. So if you look at the tides as they're measured, this is every 6 minutes for a 24-hour period. This is at the San Francisco Bay Station. You get a pure reduction down to a numerical value. And this is what I talk about when I say I use data in my work. This is the absolute reduction. What I'm interested in is what you lose when you just quantify something in numbers, and how the sensory experience of being in a place where the tides and the ocean and the sea and the feeling of being in that space is sort of lost when you reduce it down to its most basic element. So I take this and I try to build it back up into an experience that captures some of that beauty. You can also, from that website, download graphs, and this is what the NOAA's output for a graph looks like. This would be considered information because the data is then structured and organized into a graphic. So this is one day of the tide graphs at San Francisco. I took 29 of those and layered them on top of each other by tracing them 29 days because that's a full lunar cycle. And I came up with this tornado sort of pattern. And this is the point at which I switch from sort of a 2D to a 3-dimensional. My process goes through a lot of sketching, thinking about design iteration, how to create these forms into physical materials, how I can build them into something that people can then experience. This also is both digital and analog. These are some hand-cut pieces, just trying to figure out scale and proportion and how I'll represent these forms. Sometimes I go full digital and do CAD modeling for certain projects that require it. I don't particularly like sitting in front of the computer too much, so I only do it when necessary. And then these are some of the forms that start to come out of that. So I print out those graphs in a large scale, and I use my physical body to bend them by hand. So this is flat bar steel. And these pieces are about 32 inches wide. You can start to see the patterns sort of emerging from the parts that then create the final piece. So this piece is about 6 feet long and 3 feet wide. Because I have a degree in furniture design, some of my earlier work, it has a reference to furniture. This is a table, but it's sort of questioning what that function is. It's not really being a functional piece, and function has never been a design criteria that I've found fulfilling in my own work. So most of my work is no longer functional, but you get a sense of the piece as it was there. And you can see some of the secondary patterns when you look at the piece from different angles. So we live in this age of information, and it's beautiful because there's so much data that is easily accessible online. But I get the sense in my own personal feelings and more research into this that time is constant. We have an immensity of information. There are graphics about how much data actually exists in the world that are just mind-boggling. But I don't see it being applied to knowledge. And that's really why I make the work that I make, trying to bring it back into an experience. And I'm going to talk a little bit about how that progression happens, is how I think it does. So in building on science, I think science can tell us how, but that the arts can really ask bigger questions about why. When you start with data, that's a complete reduction. It's a completely objective, basic reduction of natural phenomena to a numerical or a quantitative system. To build that up into information, you need an observer, and then it becomes useful and organized, such as that graph I showed you that from the NOAA. And what I'm really interested in is transcending into knowledge, and that requires an observer, and it's no longer objective. And I believe that art is a great way to get to knowledge. This is from you also, Paul had a quote by the same mathematician. Reason's last step is the recognition that there are an infinite number of things which are beyond it. And this one's from Brian Eno. Stop thinking about artworks as objects and start thinking about them as triggers for experiences. So I want to talk about experience because of the sensory experience. It's part of my title of my talk, and that's really why I make physical representations of data. And I think the experience is the key to gaining knowledge. And I've been reading this book by John Dewey. He was active in the 30s as an educational reformer and philosopher. And simplifying one of his amazing ideas was, when we think of art, we tend to think of art objects. He believes this is a mistake, and that art can actually be broken down into two sort of parts. One is the doing, the act of making the art, and then the undergoing, which is the experience of perceiving the art. And that art is actually what connects these two experiences. So I'm often asked where or why I choose the data that I do. And a lot of it, like I said, comes from a very personal experience in the landscape. I grew up in Colorado, so I've spent lots of time on the road in the Southwest seeing landscapes like that. Sometimes it comes from learning a really interesting fact, such as this photo, sorry it's so blurry, on the left, which is the end of the Colorado River. And the Colorado River does not hit the ocean anymore because we use all of the water before it has a chance to get there. So learning about these things and seeing these parts of the landscape really makes me think about what we use all of our water for, and that starts an investigation to a new piece. This is a USGS report called Estimated Use of Water in the United States in 2000. It's actually a compilation of 1950 to 2000, so 50 full years of data for the entire United States. And it breaks it down into categorical uses. And so this center bar here is actually a graph showing you what we use all of our water for based on those 8 categorical uses. The largest one is thermoelectric cooling. So 48% of the water we use all goes to power generation. I also did not know that fact and thought it was worth exploring further to try and make a piece that gives you a sense of that fact. This is the actual table from that USGS report that breaks down from 1950 to 2000 the amounts of water for each use. And I've highlighted the 5 uses. I took the 5 largest uses and combined the 3 smaller ones so that I only had 5 categories to deal with, and you'll see why in a minute. The 2 largest uses I break down into this graph. So essentially I'm starting to think 3-dimensionally here, and this is an elevation showing you how those numbers are actually mapped in to create a form. Some of the concept development, you can see this is where my influence in terms of landscape starts to bring into the project. I want the materials I use and the forms that come out to all be inspired and related to the concept behind the piece. So in this case, I chose a canyon form, and this is before I know exactly what the data is going to look like. In this case, I went ahead and did a CAD model. I don't particularly enjoy CAD modeling, but because I'm working with data, I want to be as accurate as I can in representing it. And sometimes having a computer as a tool to help me do that can be the best way. It also allows me to have the parts ready to then fabricate the piece. So this is all of the parts that go into making this piece. And then this is sort of the process of putting it all together. So I cut each piece either by hand or with some sort of digital fabrication machine. I made 2 of these. So one of them I water jet cut the parts. One of them I cut them all with a jigsaw by hand. And then stack them up, glue them all together. It's fairly complex, meditative, repetitive process. And then these are some of the tools I use for carving back the forms to be a smooth surface. And then that's sort of part of the process of smoothing them out. And then this is the finished piece. So this has a plate of steel, and it's actually 3 cantilever pieces. It does not have a glass top, and it's the scale of a coffee table, but again, the function is not the main part of it. And essentially the data mapped in here is the walls of the canyons are wider or skinnier based on how much water we're using for different categorical uses. So on this side, at the top, it's very narrow and it balloons out. That's thermoelectric cooling water usage. And the top is 1950 and the bottom is 2000. On this side, it's irrigation, which we used to use a bit more water for, and it's getting narrower, so there's a bit less water being used for irrigation. The other 3 categories are in the tributaries that are in the other part of the table. This is where I grew up. It's had a profound impact on my life as well, as I'm sure the same is true for all of you. The mountains are very inspirational, and we don't get so much snow here in California, but it's definitely something I've spent a lot of time in and has very much influenced my work. So I decided to do a piece about Snowfall Data. This is the online database that you can search for sites all over the West. I remember the organization that runs this. The program is called Snowtel, which stands for Snowpack Telemetry, and you can search for a huge number of variables. Most of the stations only go back to the 80s because that's when they were primarily set up, early 80s, late 70s. So when you search for snowfall data, you can search for actual snow depth, or you can search for snow water equivalent, which is a bit more accurate for water forecasting, and that's what they use primarily for predicting how much water is going to be available for the public supply or for agriculture. So this is actually some numbers for snow water equivalent for a site at its pass. And what you lose in reducing snow down to just a pure quantification of number is the feeling of actually being in snow, and that's what I try to capture in creating this piece. This is a graph of the snow water equivalent for 1 year. A water year goes from October to September. So you can see the snow starts to build up, it peaks right around April, and then it all melts off, and then summer is no more. So I chose up its pass for this, and I compiled the full data set of snow water equivalent graphs. This is 31 years, I believe. You can see there's quite a bit of variation, and that you start to see some emerging patterns that I'll talk about. I then start to go three-dimensionally and come up with a form that will capture that. And that evolves over time as I draw it. And then this is the construction of this piece in the workshop. That's plywood stacked again and then carved back. This is a carcass construction. This piece actually became functional, and I'll tell you why. Each drawer represents a different year of snow water equivalent for this site. The height of the drawer is relative to how much snowpack there was, how much water was available. So some of these drawers are only 1/4 of an inch deep, and that's for very dry years. So in this piece, the function of the piece is telling you something about storage, and there's a correlation. Snow is this amazing way that water is stored naturally. We use cabinets to store things. I want there to be a correlation between how much space you have and how much water is available for a given year. Down here at the bottom, there's a really, really big drawer, a couple of them. That was from 1982 and 1983 when there was a El Nino event. So you start to see other emerging patterns. And you can imagine if they had data sets that went back much further, this might actually reveal longer-term trends in the climate. But unfortunately, climate data is just starting now to pick up to longer data sets. And there's a detail of the piece, and you can see there's one of the drawers. So essentially that is, each drawer is that graph for each year. I've more recently started to collaborate directly with scientists. I was in Portland for an art residency, and I showed some scientists at the USGS Water Science Center this graphic from 1944, which is the one section of the Mississippi River meander belt as it meandered over time. And I asked them if they had anything even close to that. And they provided me with this, which is a LiDAR scan of the Molalla River. You can see they took a scan, I think approximately every 5 years. So I only had those 4 maps. I interpolated the in-betweens and then started to figure out the form with some clay to get a sense of what it might look like. In this case, I used a CNC machine to cut out the parts. And similar process of stacking them up. I'm really trying to show how this river has changed shape over time. And you can see from this arm, there was a flood in between 2 of the maps, I think between like 2009 and 2005, which created that extra arm of the river. My most recent work is in fire data, looking at how fires change shape over time and how they grow. This is a satellite imagery of the Rim Fire, which was the third largest fire in California, which happened in 2013. This is another image from space of just how large that fire was. I happened to be in Lake Tahoe, see the lake right there, the night that it doubled in size, and that was a very visceral experience for me, waking up to like an orange sunrise and having to leave because the smoke, even that far away, was pretty intense. And this is one of the pieces I've done that doesn't actually have to do with water, but the reverse of that, the lack of water, is really what we're talking about here. So I think that the forms that come out of this are quite interesting as well. This is the Cedar Fire, and this is how fires are mapped. It's a fire progression map showing how it changed shape as it progressed between October 25th and October 29th. I just did a residency in San Diego, so this fire particularly struck out. It's the largest recorded wildfire in California history, over 2,000 houses burned. And this project has been challenging for me. I started by creating three-dimensional CAD drawings of these shapes. These shapes are incredibly intricate and ornate, and computer programs don't particularly like drawing them. I don't have as much control as I'd like. They distort things because of the geometry that the program is using doesn't necessarily create a sculpture that I can build. So I started doing these drawings. This is hand inked and then rendered with charcoal as a way to explore the form further while I figured out how to build it. And then eventually get to this clay model, which is essentially if you took those perimeters and time is the vertical axis, so you're showing how it grows and changes shape over time. So you can see that maybe the wind was blowing this direction at first, and then it completely changed direction and went up this way, and then starts to dissipate, so that only a couple spots are burning by the very end. So this is essentially a time scale representation of that fire. It's about 26 inches high, and it's a clay with an armature underneath. And this is a form study. I would like to make this body scale, probably out of a wood material. I have some wood from the rim fire, so I'll probably chop it up and use it for a sculpture so that there's actually a reference to the material that's being used and the finished piece. And that's the cedar fire as well. This is the last piece I'm going to show. This was, I finished just in the last week, and it's amazing there. I love it so much. And I did a residency a couple years ago. Ended up doing some research on glaciers because there's sort of this iconic idea of what climate change means for the world. And you can see there's a huge ice field across the bay from Homer where my residency was. So you can take a water taxi across and hike up to a glacier. And unfortunately, the data on glacial retreat is pretty much limited to the perimeter and measuring the perimeter of how much it's retreated. They don't have a great way or very much data at all about how much mass has been lost. So I partnered with a scientist at the Kachemak Bay Research Reserve who's doing a lot of studies on the perimeters of different glaciers in that area, and you can see that the rate of retreat in feet per year is kind of the standard. This is me at the glacier collecting some water a couple years ago. You can actually walk on the glacier. This one's got a big lake in front of it. This is brewing, and this is an image from, I believe, 1952, an aerial photograph showing some of the perimeters. And then this is, I believe, 2012, and it's continued to retreat further since then. So this was the maps provided by that scientist at the Kachemak Bay Research Reserve that I then used to create this piece. So again, this is taking time as the vertical element. So I take those perimeters and then graph them essentially in 3 dimensions to show how the shape of the terminus has receded over time. I then create a plywood version of that I then cast by using a silicone and then a mother mold to give it structure. And then you can pour different materials into that silicone. In this case, I chose to use water because the glaciers are ice. This piece, I ended up making a time-lapse video of it melting, which hopefully will play. And this was filmed in Colorado during a different residency. That's a big kiln yard where they were firing ceramics at the time. So it just happened to be that I filmed this while they were doing a wood fire. So just part of the video process. I was collecting water at the glacier so that I can do another iteration of this using actual water from the glacier and seeing if that changes something about the video, or kind of keep exploring. So none of these projects are necessarily finished. They all sort of evolve more and more over time. And that was it.